Welcome to the lesson, Wind in the Atmosphere. You're going to learn how heat from the sun and Earth's rotation cause global patterns of winds. The vocabulary words for this lesson are wind, Coriolis effect, global wind, local wind, and jet stream. Click each word to find out. Did you know that it takes longer to fly to the United States from Europe than to Europe from the United States? This is because of the effect of a jet stream. A jet stream is a high-speed wind belt. If a plane flies against a jet stream, it will fly slower than if it flies with it. Let's learn more about wind and what affects it. You know that the sun keeps Earth warm, but it doesn't heat all parts of Earth evenly. This uneven heating causes air to move, causing wind. Click the images to learn more. At the equator, sunlight is most intense. That's because the sun's rays strike Earth in a direct line. At the north and south poles, these rays strike at a sharp angle, meaning that the same amount of solar energy is spread out over a larger area. This makes the poles colder than the equator. It's a fact that warm air is less dense than cool air. When air is denser than the surrounding air, it sinks. We can apply this to Earth. Warmed air rises at the equator as cooler air from each pole flows toward it. This is called convection. Convection is the movement of particles from an area of higher density to an area of lower density. This movement sets up lines or belts of convection in the air. These convection belts move air throughout Earth's atmosphere. Low pressure occurs all around the equator because the warm air there has a low density. When this warm air rises, it spreads out away from the equator, moving to the north and south. As this air continues to move to the north or south, it begins to cool and sink. Cooler air is denser, so where it sinks toward Earth's surface, it creates areas of high pressure. Rising air or sinking air in Earth's atmosphere produce belts of low and high pressure at about every 30 degrees of latitude from the equator to the poles. If Earth were not rotating, then global winds would move in straight lines north and south. But since it does, the rotation seems to change the movement of air. This is the Coriolis effect, the apparent curving from a straight line due to the rotation of Earth. This change in motion is only apparent. It is not real because the object really does move in a straight line. It is Earth that turns below it. In the northern hemisphere, the Coriolis effect makes winds curve to the right. In the southern hemisphere, it makes winds curve to the left. The combination of convection belts, pressure belts, and the Coriolis effect sets up a pattern of global winds. These winds are named for the direction from which they blow. Click each type of wind to learn more about it. The Coriolis effect makes winds moving away from the poles curve toward the west. The name of these winds is easterlies. Easterlies are winds that blow from the east to the west. Find the easterlies on this diagram. The Coriolis effect makes winds moving toward the poles curve toward the east. The name of these winds is Westerlies. Westerlies are winds that blow from the west to the east. Look for the westerlies on this diagram. Trade winds are the most steady winds. Notice how the Coriolis effect makes the trade winds curve to the west as they travel toward the equator, where they meet. Let's look at some of the areas of Earth with the fastest winds and other areas that have the calmest air. The jet stream is like a fast-moving river of air, and the doldrums are like a calm lake. Click each image to learn more. Jet streams are fast-moving currents of air found in Earth's upper atmosphere. They are above the global winds that are formed by convection. The jet streams blow from west to east. Jet streams form where masses of hot air and cold air meet. Their position can shift north or south depending on the air temperature. The polar jet stream dips farther south when the temperature is very cold. Global winds set up certain patterns in the atmosphere. Along the area of low pressure at the equator, there are few surface winds. Warm air comes together from both sides of the equator and rises upward. The air does not blow north or south. Instead, it cools as it rises, forming clouds and light precipitation. Early sailors noticed this area of still air and called it the doldrums. Not all winds on the surface of Earth are global. Local winds are winds that move short distances and vary in their direction. Local winds are caused by differences in air pressure arising from the presence of landforms and bodies of water. Click each picture to find out more about local winds. If you were at the beach during the day, you might feel a cool sea breeze. Here's how it happens. Land heats more quickly than air. Warmer air over the land rises, forming an area of low pressure. Cooler air moves in from the water and replaces warmer air. This pattern of convection is called a sea breeze. A sea breeze flows from the ocean toward the land. If you were at the beach during the night, you might feel a refreshing land breeze. A land breeze is the opposite of a sea breeze. Land cools faster than water. Warmed air over the water rises. The breeze flows from the land toward the water, forming a land breeze. Another pair of local winds occur just on the land. A valley wind is a local wind that forms near the base of a mountain during the day. Valley winds flow up the mountains because the valley is warmer than the mountain, so the warmed air near the valley rises. At night, a mountain wind flows down the slopes of a mountain to the bottom of a valley. This happens because the air near the ground cools faster than the air higher up, so the cooling air sinks. A third type of local wind forms in systems of high or low pressure. In the atmosphere, air constantly moves between cooler upper regions and warmer lower regions. These up and down air movements form pressure systems. A high-pressure system, or high, forms where air is moving downward in the atmosphere. In the northern hemisphere, the air in a high